corpora today, and we're going to start with general issues related to empirical research. Corpora and corpus linguistics is about doing research using language data, which as large collections are known as or have been termed corpora, textual corpora in our case, but corpus is basically any collection of data. Typically it's used in relation to some form of language data. It may be written text, but it may be also speech data, so there are also speech corpora. They may be multiple modalities, not only speech, but also video. So a corpus is just a large collection of data. I'll come back to that later. But first of all, so we're going to look at data. We're going to look at data, and this kind of research, looking at data directly, is called empirical research. So it's mainly quantitative, but also qualitative research based related to trying to infer information based on data collections. Second of all, it may be looking at qualitatively looking at phenomena and research questions related to specific analysis, specific issues about phenomena that you might find in the data, and empirically investigating them based on data. Sorry about the typo here. And empirical research is characterized, first of all, that it's by the fact that it makes discoveries based on data. So it's discoveries based on experience rather than some kind of a priori belief or a priori theorem or hypothesis. There are two types of research, empirical research. The quantitative approach is characterized by objective measurements, typically in the form of statistics, but it's basically measuring things in a quantitative fashion. And qualitative research emphasizes understanding. So it's looking in detail at what is found in the data, how the data can be characterized, and deriving theories from these insights from looking at the data. There are two types of quantitative research and two types of statistics that can be performed on the corpus. The most basic approach would be just characterizing data by summarizing and trying to comprehend some numerical properties of the data. So, for instance, distributions of certain measures calculated from the data, distribution of values. But basically, it just describes phenomena in a quantitative fashion. This is known as descriptive statistics. And inferential statistics and inferential analysis tries to draw conclusions based on these values. So it's using statistical methods to generalize inferences based on a sample, but that would be valid also about the larger corpus, and of course about the tries to generalize it so that it's valid about the population. What kind of questions can be asked so that this kind of empirical research is meaningful? What characterizes a good research question? So, of course, we all the time think about textual data, textual corpora, but in general, there are some overarching properties of good research questions in empirical research that are important also in corpus linguistics. So a good research question asks about relationship between variables. So you want to know something about what happens with some variable when another variable, for instance, is held constant, or what happens when one variable changes, does another variable also change? This is a description of phenomena of quantitative properties of the data based on variable relationships. A research question, first of all, has to be testable. You have to be able to collect data or find a corner in your large data set based on which you can answer that question. If you don't have data to answer the question, of course, the empirical research cannot take place. Empirical approach cannot be pursued. A research question has to be, of course, clearly stated and can be formulated as a question. So it's not a claim, it's not a hypothesis. Of course, in statistical research, hypotheses are turned into questions, and very often research starts with a hypothesis. But a research question is actually a question. So when you write your thesis, be it bachelor or master, in the introduction, you also want to make sure that you can formulate a question that your thesis answers. A good research question should not pose ethical or moral problems. Of course, there are exceptions to this rule. Some research can be considered more controversial and may cause ethical issues, but they should be then considered to be by a committee that checks whether the planned experiments conform to certain rules and regulations about that conform to ethics standards that are set. Currently, the standard is set pretty much by the EU. So even if some research question involves experiments, for instance, with humans or with animals that may be more or less controversial, if the justification is good and if the conditions are met, that no harm is done, physical or psychological, to the subject in question. Of course, some experiments of more controversial nature can be performed. A research question has to be specific and self-contained or restricted in scope. You can't answer questions that are too broad at one go. It's good to split a question down into individual components and answer individual questions rather than try to answer a question that is too broad and maybe not rigorously defined due to that. And it has to identify a specific issue that you want to solve by asking this question. So there has to be something, some goal. You have to be after something so that this whole research is meaningful. What are examples of good and bad questions? So here is an example of a not so well formulated question. What is the effectiveness of parent education when given problem children? Can you imagine, can you guess or speculate why this question is not formulated? Why this question can be considered a poorly formulated question? You can also switch off. Oh, you're blocked. You should probably. Yeah, how the effectiveness be measured? Effectiveness is not defined. Very good. What else? Look at this. Here. Problem children. Yeah, exactly. Define problem children. And problem is not defined. Exactly. So, yeah. Which time scope is looked at, parent education. So exactly what you mean by parent education, all those assumptions. This question basically is based on a lot of assumptions that maybe the researcher knows something about. Maybe the researcher knows perfectly well what type of parent education they mean. Maybe they know what type of effectiveness is meant. And maybe they have something in mind by saying problem children. But as given in this form, the question is too vague to be answered in a rigorous manner. And here is an example of a question that is more specific. That is a good question that asks about a specific point on a topic that the previous question was basically too broad about. So read this question. What is the effect of the STEP parenting program on the ability of parents to use natural logical consequences as opposed to punishment with a child who has been diagnosed with bipolar disorder? So Here we know what kind of problem children we mean. Of course, problem child is a controversial term in itself. Now we know that it's about bipolar children. Well, a problem child is a negative has a certain negative connotation or carries a negative polarity. Well, a bipolar disorder is a disease. So why should you call bipolar children problem children? So it's already introducing a certain prejudice or certain negative bias with respect to a disease. Here we have an explicit specification of what type of parent education we mean, STEP parenting program on the ability of parents to perform certain parenting functions. Here, natural behave in a natural, logical way, such as the consequences are known as opposed to punishment with respect to the children diagnosed with a certain disease. So here everything is known. And we are asking about the effect, and this effect is measured using some variable that is previously defined. This variable probably is not, should be included in the measures part of the paper. But you see the difference here. It's hard to answer an open-ended question with vague elements in it, with vague concepts in it, but it would be much easier to try to find an answer to a well-formulated, clearly defined question. So we also want these kinds of questions in corpus linguistics, of course. We can't ask about broad concepts that are not well-defined. So corpus linguistics is about doing empirical research in with language data, on language data. What type of research is it in general? NLP may be used to study language in corpora using algorithmic approaches. So you developed tools, NLP tools, to evaluate those tools on collections of data. On the one hand, you're evaluating the tool. On the other hand, you're learning something about the data. What is also important in corpus linguistics is that these evaluations are also rigorously defined. Without a good evaluation, of course, you can't be sure that what you've learned makes any sense. You can't be sure that the conclusions you draw are valid even. The experiments are evaluated, in our case, in case of corpus linguistics, on corpora that are distinct from what the experiment is conducted on. So typically an experiment is conducted on a subset of a corpus, and the generalizations are verified on a corpus that is distinct, on a subset that is distinct from that first corpus on which an approach was developed. And using this approach, it's also possible to perform hypothesis testing. So research which try to verify whether results of an experiment are meaningful, valid, or whether they happened by chance. So with an approach that strictly or clearly defines where the subset of data on which a hypothesis is defined and tests it on a subset of data that's distinct from that first subset, you make sure that the conclusions are generalizable, that the conclusions, the inferences are valid. And rigorous hypothesis testing is one of the key methodologies that are used in traditional corpus linguistics. Of course, nowadays, a lot of corpus linguistics is done using machine learning, and this traditional hypothesis testing approach is, I would say, they in the minority of corpus research nowadays. So So corpus linguistics, like I said already, is a study of language as it is expressed in a natural form in collections of texts called text corpora. I already mentioned that these collections of text are referred to as corpora. These corpora may be, of course, here we say that it's natural language texts. And so this is a text that appears as it is naturally occurring. Of course, there may be studies that collect specific corpora that result in texts that would not appear in natural situations where the setting is to some extent controlled. So this is, you could consider it a naturalistic setting, but this language is produced under certain predefined conditions. This is, of course, also possible. The goal is to derive knowledge from real-world texts, so from real-world language or language under controlled experiments. And traditionally, in the beginnings of corpus linguistics were set in manual counts of data, the way it looked in the corpus linguistics is actually very old. It started in the depths of cloisters, was performed by monks, originally based on mainly religious texts, specifically on the Bible, and all the counts were done manually. So tallies of words, for instance, were counted manually. Of course, nowadays all of corpus linguistics is performed computationally. And there are three main techniques that are used in corpus linguistics. The analysis is about developing and evaluating methods based on corpus, so analyzing the corpus and developing tools, techniques, and hypotheses based on these analyses. A very common technique used in corpus linguistics or methodology is approach, let's say, is annotation. So coding data with certain categories that are of interest relevant to the phenomena under study, which facilitates then further qualitative and quantitative analysis of the given phenomenon. But in a data-driven approach, again, once you have the codes, you can perform statistics on the codes, on the annotations. And the abstraction methodology, I would say, is least represented in the world of corpus linguistics, and that's mapping of annotated text to a theory, some kind of theory-based model. This would basically amount to doing a kind of hybrid research between a qualitative approach and a quantitative approach with statistics and a qualitative approach, where you would like to verify some theory about a phenomenon using a corpus. So you don't see as much of this last approach in NLP. However, in linguistics, this is a common approach. So there is some linguistic theory that you postulate about some phenomenon. And then using corpus methods in theoretical linguistics, you could try to verify this theory about the language. So not so much of this in NLP, but quite a lot of this last approach in linguistics. So of course, for all this, we need text corpora. You can't do any of this research without the data. And as it's especially nowadays the case with modern computational techniques that require a lot of resources, a lot of data to learn from, especially in machine learning, the more data, the better. Of course, there are caveats to having the more data, in that the more data you have, pretty much anything can be inferred statistically. But for the most part, I would say the larger the corpus, the better. However, a corpora also should possess certain properties about which we'll talk in a moment. So what is a corpus? Let's define a corpus in a more rigorous way. A text corpus is an electronically stored. There is no other way of storing corpora these days, pretty much, collection of data that is designed according to specific design criteria to be maximally representative of language or a particular variety of language or some other symbolic system. And typically the basic unit for representing text is a word. Word is a unit that captures meaning. Of course, you remember that from previous lectures that some phenomena require analysis below word level, and of course then these units would be below word level. These may be morphemes, these may be syllables, or even characters. But typically the smallest unit of representation would be a word. Examples of corpora, we already mentioned some even in the introduction. We looked at this example of a review and a task of information extraction. This might be a corpus, for in this case, based on a corpus, in this case, of reviews. Such a corpus might contain several 100,000 of those reviews scraped from a website or scraped from a forum. Another example of a corpus or a corpora that were very frequently used in the beginning of computational approaches to corpus linguistics are news articles. News articles initially appeared not in a form as we see them now very often, news on the websites. They appeared in the form of newswires. So literally the text that is that comes into an editor, a publisher of a newspaper from a press agency, such as from a press agency. So a raw text, uncorrected text. It might have contained spelling mistakes. It might have contained contractions. But a news article, some kind of news article, collections of news articles are very common sources for building models in machine learning. What do we mean by this representativeness here? So the key of this definition of a text corpus is that it has to be representative of a language or some particular variety of a language. So this representativeness is a key concept in corpus linguistics, actually. And representativeness is can be defined in various ways, and various corpus researchers emphasize different aspects or angles to it. Biber, one of the earliest computational researchers who worked on corpora using computational tools, defines representativeness as extent to which a sample includes the full range of variability in a population. So remember, you only have a subset of the data that appears out in the wild, and you want to draw conclusions based on this. So you would like to have the sample that is most representative for what might be out there, so that the system generalizes. This may be a corpus of stemming from some area, let's say in the English-speaking world. What you have to keep in mind is that somewhere else in the English-speaking world there are different varieties of English. So what the conclusions you might draw from a sample of data that you take from, let's say, speakers of British English might not be representative of the data that you might get when you collected the data in the US. So this is one issue. Jeffrey Leach, again, one of the most famous figures in corpus linguistics, says that the corpus is thought to be representative of the language variety. Again, here we emphasize language variety. So, for instance, the specific variety of English is supposed to represent if the findings based on its concept can be generalized to the said language variety. So this is the key here. If you find something on the sample, you're assuming, or you want the sample to be such that you can assume that the same will be true of the whole language variety that you're working with. So if you find a certain feature in the corpus, we are likely to find the same feature in other further data of the same type. You can, however, ask a question: what is representative of the users of a language? And Sinclair, again, one of the very famous figures in Corpus linguistics, says, according to claims, the most likely document that an ordinary English citizen will cast his or her eye over is the Sun newspaper. So in Germany, the cultural analogy would be something like Bild. And Bild is probably not might be representative of your average citizen. However, it's not representative of, for instance, the academic population. Probably. There are other newspapers that are completely unlike the Bild, for instance, the Frankfurter Allgemeine, or in case of British newspapers, the Time or the Times. So what is representative of the users of language might not be representative of the overall average language that is spoken in the given in the area of the given language variety, but by other subpopulation of that of those users. So this is a very interesting observation and a very interesting point about the opposing sides of what language is about. On the one hand, it's about what you're exposed to, what kind of language you're exposed to. This is reception, and on the other hand, the kind of language that you're likely to produce. This is production. And even those who are exposed to let's say, the more highbrow, in colloquial English, newspapers such as the Times, so the reception might be of a rather sophisticated language, they will not produce the same kind of language in everyday speech. So this is this discrepancy between, on the one hand, the language that is produced, and on the other hand, the language that is that the user is exposed to. So representativeness has these interesting aspects to it that has to be taken into consideration when first formulating a research question, and second, building a corpus. But for sure, representativeness is important for generalization, because otherwise none of the inferences might be valid and probably might not hold. There is another concept that is critical in corpus research, and that is the concept of the data being balanced, or some phenomenon within the corpus being represented in a balanced fashion. And this is what this figure illustrates here. So we said that a corpus is representative for some phenomena or some concept, let's say in this case C, if it includes a full range of variability of this concept, with respect to this concept, right? So the distribution of texts over the levels of this variable C, of this concept, should be representative to the real distribution, or we would like to make sure that it is. And balance is with respect to some variable or feature, means that if this variable has different angles to it or aspects to it, let's say the variable, by variable we might mean something like gender, male versus female. So in this case, this variable has what we call in statistics 2 levels. And balance means that none of the levels of this variable should be overrepresented in the corpus, should dominate in the data. So the distribution of the levels of the variable should be balanced within the data set. I gave you only one example, but this holds of any type of variable. So we talk about a balanced corpus when all the values of a certain phenomenon, certain concept, in general a variable, are evenly represented. And this is favored over unbalanced distributions because let's look at this picture here. This is what you would consider an unbalanced corpus. We have here 5 levels of some variable. This is it's independent of what this variable is supposed to represent. We just have 5 levels of some variable, and we see here that this level takes up 40% of the corpus. This level takes up about 30% of the corpus, and then the levels 1, 2, and 3 much less than these two. What we have here is that these levels, 5 levels of the variable, are evenly distributed. We talk about this this kind of distribution as being balanced. So why is it important? Because imagine now we sample from this corpus and we sample from this corpus in machine learning. We want to build a model. In the case of this data, we are much more likely to repeatedly sample values from this level because they are overrepresented than values from this level. Whereas here, in this case, all the levels of the variable are equally likely to be sampled in random sampling because they are evenly distributed. So this balancing aims to reduce bias, for instance, in sampling, and so to mitigate some of the phenomena, some of the consequences that this bias might introduce. Is this clear, the distinction between representativeness and balance? Sorry about that. Let's go back. Yes, I was just saying that I'm going to skip the part on encoding and ask you to read about encoding yourselves. The point here is that because we won't have time, otherwise we won't finish. Because the main point here is that textual corpora, of course, stem not necessarily only from Latin languages, but it may be in languages that for instance, are characterized by different types of script. So in order to be able to work with the data, ideally, especially if multiple languages are included, you'd want to make sure that they're encoded in the same way. So this problem of character encoding is that of identifying a way to encode the languages, the data sets in a uniform fashion, and typically this is nowadays done using the UTF-8 encoding. I'm just going to ask you to read through the slides on encoding yourselves, and if you have questions, we'll ask. We'll discuss them next time. Okay. So what in practice, what doesn't, and actually, why am I constantly on video and I'm using my bandwidth? I'm just going to switch off the video because I see a little delay, and I'm getting annoyed by the fact that I say something and it appears delayed on the video. So I'm just going to switch off the video. Okay. What does this? They were talking about textual data, and what does this data look like? You'll read up on encoding at home, but essentially, corpus basically is just a you could say in the most general case, a concatenation of the characters of a given language. So it's a concatenation of elements from that alphabet. You have multiple examples here. A concatenation of characters of Latin alphabet in English, a concatenation of numbers here, or a concatenation of any characters of any given language. And essentially, this is the most basic data that you deal with computation linguistics. So the most basic element of a corpus will be a string of characters, and the most basic linguistic unit would be probably a word. So the kinds of operations that you performed on the corpus, we already mentioned some of them in pre-processing. All this pre-processing that we talked about last time will be relevant in corpus analysis, of course. We talked about it in the context of some NLP tasks, but it will be also, it's just as well valid in the context of corpus analysis. So you might have to split the string of words into individual words. We'll talk about tokenization later. You might want to perform some case conversion. We talked about the basic pre-processing type element. That is converting all the words or the text into lowercase, identifying certain substrings in the words, and so on. But conversely, you might also identify some other compound elements, and you can think about a document as being a compound data type, as in general, in the most general case, which is a collection of strings plus some metadata. So a document essentially is a collection of words, structured collection of words, and maybe some additional information that comes with it. We'll come back to that. And the corpus, from a practical point of view, is a collection of those documents. When you think about words, and we'll come back to word classes later, to what types of words there are. But a word is a kind of an abstract concept that represents some semantic construct, some semantic concept. So you can think about those as, from the point of view of semantics as referring to classes of things of certain type. We call this approach, or this view on a word, as a type-oriented approach. So it's a word, seeing a word as a type representing a certain class. An individual instance of that word, so a specific mention of that word, the concrete string that appears in the document, we'll call a token. So it's a specific instance of a meaningful concept mentioned within the text. So here you have in this, on the left, a set of concepts: discipline, distinction, concept. And these concepts are mentioned in a document in this form. In disciplines such as knowledge, representation, and philosophy, the type token distinction is the distinction that separates a concept from the objects with a particular instances, which are particular instances of the concept. So here in this text, which defines the type token distinction, you have instances, specific mentions of concepts. So in this case, here are the tokens that evoke certain types. So it is important to see this, because this type token distinction is one of the key distinctions in corpus linguistics. And actually, the measure called type token ratio is so a ratio between the types. So overall, the set of concepts mentions overall the set of instances mentioned is one of the common measures that is used in corpus linguistics to measure, for instance, the lexical diversity in text. So the concept of the type and token distinction is something that I would like you to understand clearly. And is this, could you just say yes or no whether there are questions to this distinction? The concept of a type versus a concept of a token. So one is a class and the other is a specific instance, a specific occurrence of a, okay. Okay, good. So what is then vocabulary? Now that you have this notion of type and the token, then now you can see that vocabulary is actually a list of all the types occurring in a document. A vocabulary in general, what is in the dictionary, is a collection of types. So now you can see your dictionaries, your lexica, as listings of types, and the individual tokens appear in specific documents. So it's a distinction between the mention versus the concept as such. Semantics. I already talked briefly about text models last time, but now you can see this transformation of documents into numbers was basically taking the set of concepts, so that set of types, and transforming them into matrices, where the matrix actually represents the observations, observations of the individual tokens in the document. So now you can see the transformation of text into vectors, into numerical objects, as taking a vocabulary of types and representing them as vectors that contain information about the occurrences, so about the tokens. And machine learning will operate on those representations to discover patterns in them. Okay, the second element in the corpus is metadata that are mentioned. This metadata may be of different types, and they are external to the document. So they don't. They may be encoded using vocabulary from the document, but they don't contribute to the vocabulary of the document. They are just information that at the meta level. What can it be? It may be information about, for instance, the time that a document was produced. It may be a representation of what type of domain a specific document is about, what kind of, or a specific section is about. It may be any other variable that somehow characterizes the document that might be relevant for statistical analysis. Okay, so this concludes a brief introduction to what corpora are. Now, what can one do with corpora? Of course, it would be interesting if corpora could be used in some interesting ways rather than for doing research. There is applied research in corpus linguistics, and here is an example of one of the earliest uses and the earliest research in corpus linguistics on corpora, which, however, now has a very goal-oriented application in language learning. So this concept of concordance, so building an aligned representation of the corpus with respect to a specific word or phrase, was one of the earliest kind of tasks or earliest results of this early corpus linguistics. There was actually long concordance listings done for the Bible, And here you see an example from a corpus of the English web corpus with a concordance of the word context, specifically of the phrase in with the determiner the or without, with some modifier, and followed by the word context. So any prepositional phrase that starts with in and ends with context, in humanitarian context, in the social context, in the context, and so on. And the concordance basically collates the left context of such phrases and the right context of such phrases. What is it good for? Well, while learning language, you can learn about the use of this phrase, for instance. So you can immediately see in what contexts exactly, as here, represented here, these phrases appear. So you can learn about the usage of this phrase. This is what concordance research is about. And this specific screenshot is from a tool called Sketch Engines. I very strongly recommend to all of you. There are a lot of different corpora included in this tool, and it's mainly dedicated to lexical research. But if you're interested, I very strongly recommend to go to the website and check out the tool. Not everything is available in the free version, but look at the idea. So what can one do by way of basic statistics with corpora? Again, here an application from our group in Weimar. Similarly, you can, based on a corpus, try to look for phrases and look at and ask which phrases or which formulations in this case are more frequent than others. So we are looking here for a string that starts with waiting and then a response or a synonym of response. And we get a listing of phrases from a corpus where the first word is waiting and the last word is the word response or its synonym. We'll come to synonyms when we talk about semantics later and when to get synonyms from. And what we are interested in actually is what kind of preposition is used in the context of waiting and answer or response. It turns out that the most frequent formulation is waiting for an answer. This is what very often you do with Google. This screenshot comes from a search engine called Netspeak that uses web data and performing this kind of phrase analysis. But this type of analysis, again, also has a good application in language learning. So here you see there's occurrences of waiting to an answer. There's much fewer occurrences of this phrase with respect to, by comparison with the most frequent phrase, waiting for an answer. But this shows, of course, that in corpora you might also find, if you're using natural language corpora, natural corpora as they occur in the real world, you might also find ungrammatical formulations. So as part of preprocessing, you might want to filter them out if you want to have only valid language in the corpus. But in this case, to show a learner that this is not a valid construction, it's actually maybe informative or educational to include it. And to include especially the count would be indicative that this is an ungrammatical construction or this preferred construction at least. Okay, so this concludes the basic introduction to corpora. Other questions at this point? Okay, there are no questions. Is someone typing? Not so far. Okay. Okay, so like I said, corpus linguistics is on the one hand about qualitative research, but for the most part it's about quantitative research. So we want to count things. And we want to formulate research questions that you can answer using quantitative means. So what kind of questions can we ask about a corpus of a corpus? Let's say we've collected a corpus, scraped some web pages, or downloaded a dump of Wikipedia. What can we ask of this corpus? Well, we can ask very basic things like, for instance, how many words are there in this corpus? This is a very basic question, but already this question poses certain problems. And here are some examples. First of all, you have to ask, how do we count? Well, here is the word bank. This bank, as you know, is a polysemous word, and there are two meanings of this word bank: bank, the financial institution, and the bank that is that land alongside of a river or lake. So it's a river bank. And there's also occurrences of the plurals, and some of those plurals will be referring to the financial institution, and some of the plurals will refer to the other bank, the bank on the side of the river. So how do we count? Do we count all these occurrences? We are interested in words. Are we interested in their meanings? Maybe we are in both. Maybe we are only one on the other. We have to know what you're interested in. So you could think of an experiment in which you do the following. This is a little experiment that will lead us to an interesting property of text. We'll count words in a text from left to right, from the beginning to an end, and count every new word seen. In this case, we will not care about the two different banks. We'll just assume that the surface form of a word is what we count. So we won't even make a distinction between the plurals and the singulars. And we will count how many words we have seen so far. So these will be the tokens. And we will count how many different words we have seen so far. So these will be the types, of course. And we want to know, in this case, how does the vocabulary, so the set of distinct words, remember this distinction between types and tokens. The individual words are the tokens, and the different words are the types. I was interested in the question of how the vocabulary grows. So as we read more, do we somehow at some point reach all the vocabulary, or what does it look like? Is there a pattern to how the vocabulary grows or not? So we're going to try to plot this. What's your intuition? What's your intuition? How is it going to look? What could this plot look like? It will soon stop growing, the number of types. Okay. Soon stop growing. Yeah, okay. Hopefully at some point we'll reach some kind of oh yeah, okay. Good. So we have some kind of exponential growth. Okay, so let's actually do this experiment, perform this experiment. And we're not the first one who thought about this experiment, of course. But this experiment was designed to test a hypothesis actually about vocabulary growth. And this is exactly the plot that we asked about. This plot was done based on a specific corpus. This is the news corpus from Associated Press, a quite old one. On the x-axis is the number of words in the collection. And on the y-axis, you have the number of words in the vocabulary. So these are distinct words, so distinct instances, and this is the types. So this curve represents the vocabulary growth. So as expected, so it's not, it's actually not like either of you thought. It's not the case that the vocabulary stops growing soon. The vocabulary grows constantly. And it's not exactly this kind of clearly, I mean, it's a power-based growth, of course, but it's not this kind of clear exponential growth. You see it? But there is a pattern to how the vocabulary growth can be modeled, and it turns out that this pattern of this kind of steady growth holds between corpora, and this is what the Heaps law represents. So here you have the certain parameters that are characteristic of the collection, and for this specific corpus, these parameters that model that curve that predicts the vocabulary growth in this collection. It's dotted, the dotted line here. These parameters has to be estimated from corpora, and they n is the number of non-unique words, so the specific tokens in the corpora. And it turns out that this law holds across document collections. So this is kind of surprising because it means that there is something that is universal to vocabulary growth across document collections. First of all, just take a moment to look at this curve, to look at the parameters, and see if you understand it. Make sure you understand it. Okay, you have a question? Yeah. I was considered across different languages. Yes. Yes, basically. So this is a universal observation about the growth of the vocabulary with relative to document length. It's related to another law that's also universal across languages that we'll get to in a moment. So what does it give you? What does this law give you? Well, you can estimate the vocabulary based on the number of words you've seen of the document. So let's say you've seen 30 million words. You can estimate that the vocabulary you've seen is about of that order. Yeah. So this is an interesting and unexpected, yes, some kind of a surprising property of a collection of documents. And here is, sorry, in my throat. And here is another example of a different corpus, and you see that the same property, it has the same property holds. This is a different corpus now. A corpus of governmental documents. The parameters are different, but the pattern is the same. So the conclusion of this is that the vocabulary grows continuously in large collections of documents. The larger the collection, the growth of vocabulary will actually, you could say, never stop. So V of n will soon stop growing. No, it's not the case. And why is it not the case? Well, because there are certain artifacts in large collections of data. For instance, these new words might not be really new words. There are artifacts that are unexpected or due to just human error. For instance, the spelling errors. There are new words. New words are constantly invented, right? There is code. Maybe you have some specific or some very unique documents that contain, for instance, unique instances of numbers. Maybe there are foreign languages in this document. In a large collection, you might have documents that contain languages that are even switched or swapped within one document. If you download all of Wikipedia, you'll have a lot of different languages, of course. There may be constructs that are unanticipated upfront, such as email addresses or URLs and so on. So these new words might not necessarily be new words, so the set of vocabulary is not exhausted due to artifacts also. But that's a conclusion, so it's an interesting conclusion that you also have to keep in mind when you create models of language. We'll come to language modeling later, that there may be vocabulary that you don't expect, and some of this vocabulary may be due to artifacts. Okay, there is also another interesting and hard to explain, or actually explainable in different ways, phenomenon about data collections, textual data collections, and that is known as Zipf's law. This is probably the most interesting or properties of textual data collections, and that is universal across languages, and it's actually a property of language. So this is not only a phenomenon related to a corpora, it's a property of language to some extent. So this phenomenon is about the distribution of the frequency of words. So you could say that what would be your intuition about what the most frequent words in English are? Well, probably the most frequent words are the ones that you have to use anyway because of the properties of the English language. So English is characterized by articles. And so this article, in this case, the and a in English, or an, will appear very frequently because by the properties of English grammar, you have to use it with every single noun. Of course, there are instances of nouns which are called bad nouns, and in some cases, such as generics, for instance, penguins don't fly. Penguins doesn't have an article in this sentence because it's used as a generic reference to the species of penguins. But for the most part, articles are required with noun phrases in English. Also, to create, for instance, genitive constructions, the preposition of is used. So prepositions might be very frequent because they also represent spatial relations, temporal relations, and so on. So you could expect that there are certain words that will appear frequently and other words will appear less frequently. So you could have this distribution. You could already sense by this that distribution, or that the distribution of word frequencies in language will be skewed. So there will be some words that occur very frequently and other words that occur less frequently. And it turns out that the set of words that occur very frequently is rather small, and the set of words that almost never occur or occurs fewer times is very large. And this property was observed by an American linguist, George Kingsley Zipf, and he studied this relationship, statistical relationship between frequency of words and its rank. I will show you in a moment what this rank is. and formulated what is now known as Zipf's law. And the Zipf's law holds not only of language, but of many other phenomena. So we're going to ask the following question. What is a frequency of the of tokens? And we are going to order tokens by their frequency. And we're going to ask what is the count of those tokens? So how many times the token of this rank appears in the collection? So, sorry. Okay, sorry about this. I had a problem with my throat. Okay, so we're going to plot. Where were we? Yeah, we were in the. We're going to plot a rank order in the. We are going to order words by their frequency and plot the rank of a word by its frequency of occurrence. So on the x-axis, you will have the rank of a word as it appears in the list of words ordered by frequency. And on y, you have the frequency of that word. So, and this relationship results in this distribution that you see here. It turns out that the most frequent word, which in a moment you will see what they are, what specifically they are based on a specific word collection, appears about twice or so, more or less twice as often as the next most frequent word. And then the next most frequent word relative to the second one appears half the times of the second one. The third most frequent word appears about half the time the second one appeared. The fourth appears about half the time the third one appears, and so on. And so in general, the observation is that the word frequency, so a frequency of any word, is inversely proportional to its rank. And this is what's expressed by this power law here. Sorry about that. That's what's expressed by this by the equation here. So we have here a relative frequency of a word. So frequency of a word in a large text collection correlates with the frequency rank in this power law. So this rank you see here, and there are two parameters that are specific to a language. One is a constant and one is a language dependent. Sorry for this. My voice is just really bad today. Yeah. So this frequency of a word is correlated inversely with the frequency rank of the given word. So it turns out that for instance, that the most frequently occurring word for English, the word the article, as we already hypothesized here, and as we can see by observation or by properties of the English language, it turns out that it accounts for nearly about up to 10%, depending on a language collection, on a text collection, 10% of all the words. The next most frequent word will be for English will be the word of. Here is the actual frequencies for the top 50 most frequent words from that Associated Press corpus that we saw earlier. So the word the is most frequent, the word of is the second most frequent, the word to is the third most frequent, a and in, said, for, that, and so on. And these are the frequencies. So look at the ranking of the words, and what do you see? What can you tell me about these words just by looking at them? Can you see something? What kind of interesting properties do you see about these words? About 0.8, 0.08. I guess C. Yeah. So that was another question about that. But look at the words. What can you say? Can you see something about these words? The words themselves. First, this is not the end of the Zev story about words. That's universal too. Many short words exactly at the top. What kinds of words are they? Mostly particles. Yes. Yes. Yeah, the two most important properties you already noticed. What else? Pronouns. Yeah, exactly. So the key observations you already have. So first of all, at the top of the list are what can be, for the most part, considered function words. So they are parts of the language system in terms of grammar, and not so much of the language semantic vocabulary. So you have articles, various types of particles. You have here was, and was is a verb, but was of course is a part of a grammar construction. Matthew was typing. Was is of course part of a grammatical construction to form, for instance, past continuous. There is a word said here, and said is apparently used very frequently in reported speech, right? Have is a part of a tense construction, but is a conjunction. Here is a pronoun. Pronouns are used to replace to replace mentions of specific entities. And a semantic word that's first in the list, in this case, is percent, and here is people. So at rank 50, you have a word that is the first, let's say, yeah, semantic word, and that is relatively, it's not a long word. Percent is longer, but it's longer relative to the short words that are at the top. And this is a second observation that is transpires from the Zipf's law, that the most frequent words are those short words, and the most of the vocabulary, basically, most of the language that we both perceive and speak consists of those short words, and only relatively little in terms of frequency of the vocabulary that we perceive and produce are longer words. And I will ask you to read up on, because my voice is basically disappearing. Here's here is ranking, the same ranking. I know this is still the same. Yeah, sorry, I removed the slides because I had a ranking for a different document for a different document collection, where you would see that the same pattern holds and basically the same vocabulary recurs as the top. And I will ask you to read up on what may be the explanations for the Zipf's law. This may be there's an explanation related to economy of the language use. It's easiest basically to pronounce those short words, so it's kind of intuitive to say that the most frequent words would be the words that are easy and fast to produce. And from the point of view economy, imagine if a word that you have to use together with every single noun phrase consisted, let's say, of 5 syllables. So with every single noun phrase would have to also pronounce an article that consists of 5 syllables. So this would be rather suboptimal in terms of language production. So these function words, this explains why the function words are the way they are. It is observed that oh my God, sorry, my voice is going. Sorry about this. The Zipf's law holds of across languages. So this is a universal observation, a rather striking observation. I will ask you to read on the explanations of the Zipf's law after the lecture. And I'll have to finish now because my voice is really pretty much dead. Are there any questions at this point? about the Heap's law or about the Heap's law or the Zipf's law? The slides also include the calculation of the estimation of the relative frequencies. You're also welcome to look at that. And I will not go through this. This is a logarithmic presentation that highlights basically this inverse linear relationship of the same law. So here you see actually the inverse in the inverse linear relationship. Are there any questions? Okay, if there are no questions, then we probably should conclude because it's the time is anyway over, and the remaining slides are basically additional slides that elaborate on the derivation of the Zipf's law. They are included in the website, and there's also statistics related specifically to information retrieval, which we do not cover here, but you should also look through. Yes, so if there are no questions, then we could conclude for today. Or you could also ask questions. You could basically digest the slides. And next week there is no class. Announcement. Sorry about this. There's also an announcement. Next week, as far as I know, there is no class because there is a public holiday called Kristi Himmelfahrt. So there is no class, but there will be slides. And I will ask you to go through the slides on your own. The slides will be about language modeling. And I will start the next session on the 20th with questions to today's slides and the next week's slides, the ones that you will read at home. Okay, so if there are no questions, I saw Katarina typing, but she backed out. No, Carolina. She backed out, so if there are no questions, I guess we can conclude today's session. Okay, so thank you for today and see you on the 20th.